In this video, we're going to do another projective geometry construction known as Brianchon's point. And we're going to begin like we began with Pascal's line. We're going to have a circle, and we're going to pick 6 points randomly on that circle. Doesn't matter where you pick them. Then we're going to do something specific with those points. We are going to do, and different from Pascal's line. Pascal's line, we connected the points. That is not what we're going to do here. We're going to do actually the dual of that. We're going to find the tangent line that is associated with each of these points. Now, what is a tangent line? If you remember, if you have a circle and you have a point on that circle, the tangent is the line that goes through the point and only touches the circle at that one point. It's a very specific line, and any point on a circle only has one tangent line, and that's what you want to find. And you'll see how I did it here. The tangent line has the same angle on this side of the point as it does on that side of the point. You have to be really careful in drawing the tangent line so you get the actual single tangent line for this to work as it's supposed to work. All right, so now that you've done that on your own drawing, and again, you can do this on the computer or you can do it by hand if you can get yourself a nice perfect circle, either way. You're going to look for the points where consecutive tangent lines intersect, and you have to find the right point. I should say the proper point. So this, by the way, is point. So anyway, here's all the tangent lines. There's an intersection all the way out here. It's outside of the range of the page. I'll call that point 1. Point 2 is the next intersection point associated with this line and the next line. Then you have point 3, that line, and that line. And then point 4 is going to be the line that also is part of point 3, and the next line where those two intersect. Then point 5, then point 6. So notice the points are where the consecutive tangent lines intersect. Just like with Pascal's line, we're going to identify those points that we want to have tied together. For Pascal's line, we looked at lines 1 and 4, 2 and 5, 3 and 6. For Brianchon's point, we're going to look at points 1 and 4 and connect those with a line, 2 and 5, and 3 and 6. So that's what the next slide is going to do. Well, actually, 2 slides down. So this is all I did is I stated what we're going to be doing. But what's interesting is, remember, when you have any 2 lines are going to intersect at a point, even 2 parallel lines. They're going to intersect at the point at infinity, which is either above or below, but it's still considered a single point. But when you have 3 lines that all intersect at a point, that's special. And that's what we're going to get right here. It's always going to be the case if you do the construction, like I said. You will always get these 3 lines that cross at a given point, and that point is called Brianchon's point. And this was actually the one that came later. Pascal's line was discovered, I think, in 1640. Brianchon's point in 1807, 167 years later. You say, well, so what? What's the big deal? They're actually, in some sense, one and the same. They are what are called duals of each other. Let me try to explain that to you. In Pascal's line, we took a circle and selected 6 points randomly on the circle. It's just like we did for Brianchon's point, but in truth, we actually picked a circle and selected 6 lines on the circle for Brianchon's point, because the line is the dual to the point. Where those consecutive lines intersected, we had a point, just like where the various points that are connected in Pascal's line, they were connected by lines. So that's another dual situation. And then I took the opposite ones, 2 and 5, 1 and 4, 3 and 6, and either connected them in the case of this, or in the case of Pascal's line, those are the lines I joined together to create a point. Those are dual situations. Here, we have the unique situation that we have 3 lines all intersecting at a point, and in Pascal's line, we had the unique situation where we had 3 points that will always line up to be a line. That is an example of a dual, and these were 2 things were discovered independently, And then later on, it was realized, wow, they're actually, in a sense, one and the same. So there's a lot that we can talk about here. But I wanted to give you this explanation and give you the chance to construct Brianchon's point yourself, either on the computer or by hand, and then submit it along with the rest of this week's assignment on Sunday.